Now let's find the electric field due to an arc of charge. And we're going to look for the electric field specifically at point P at the center of the arc. Once again, this situation does not have enough symmetry for us to apply Gauss's law. There's no Gaussian surface that we could draw for which the electric field would be a constant on that surface. So instead, we're going to have to find the electric field at point P by integrating. So let's consider a little piece of the arc. In this case, I'm going to say that this piece spans some angle d phi and is itself located at an angle phi above the horizontal. Again, we're going to think about that piece as a point charge that creates some electric field at point P. And we're going to add up the contributions to the electric field of all of the little pieces of arc in order to get the total field at P. Since we're going to treat this little piece of arc like a point charge, we need to know the charge of that arc, dq. The total charge density of our rod is lambda, so the charge density of our piece will be lambda times the length of the arc. Here I'm using s to represent an arc length. If I measure my angle in radians, there's a very simple relationship between the length of the arc and the amount of angle that it spans. ds is equal to the radius of my arc times d phi, the amount of angle that it spans. So that allows me to write the charge of my piece of arc as dq is equal to lambda, the charge per unit length, times the length, which is r d phi. So at this point, I could write the electric field due to my one little piece of arc as dE equals 1 over 4 pi epsilon naught times the charge of my little piece divided by the distance between my piece and the point where I'm measuring the field, squared. You might be tempted at this point to just integrate that expression for the entire length of the arc. But notice that the electric field of this piece has a horizontal component and also a vertical component that points downward. And on the other side of the arc, there will be a little piece that has the same electric field but with a vertical component that points up. The vertical components are going to end up canceling out. For every point on the arc that's above the x-axis, there will be a point on the arc that's below the x-axis for which the vertical components will cancel. So ultimately, I'm just going to add up the horizontal components of the pieces of arc